A small plane leaves the airport traveling to Chicago at a speed of 180 miles per hour. A larger plane leaves the same airport 40 minutes later, also traveling to Chicago, but at a speed of 250 miles per hour. How long, in hours and minutes, will it take the larger plane to catch the smaller one? Now, the first thing you have to realize is this. If a small plane leaves heading for Chicago, so this is airport A and this is airport B, okay? And a larger plane leaves the same airport and catches this plane. They have traveled the same distance. So the first plane and the last plane have traveled the same distance. And so, what do we know? We know that the small plane's distance equals the large plane's distance. Okay? So we know the large plane and the small plane, their distances are equal. And to make my life easier, I'm going to call the small plane plane number 1. Okay, I'm going to call the small plane plane number 1. And I'm going to call the larger plane, okay, I'm going to call the larger plane plane number 2. So I'm going to call the larger plane plane number 2. So the small plane's plane 1, the larger plane is plane 2. So I know the distance of the smaller plane, D1, has to equal the distance of the larger plane, D2. Now what this means is, if you leave your house and you go a certain route, and then later someone leaves your house and they go the same route and they catch you, they had to have traveled the same the same amount of distance to catch you. Okay, and this is the same case here. Now, what do we know about distance? We know that distance equals rate times time. So D1 is going to equal R1 times T1. And D2 is going to equal R2 times T2. Because there's that old formula, distance equals rate times time. Well, I have 4 variables here. Okay, I have 4 variables here. And I need to somehow get this down to one variable. So, I plug in rate 1. What is the rate of the smaller plane? Well, the smaller plane was going 180 miles per hour. Okay, times T1. And the larger plane was traveling 250 miles per hour times T2. So now, plugging in their speeds or their rates, I've gotten this problem down to 2 variables, T1 and T2. Well, I don't need both of them. I need one of them. And I look at the problem and it says, how long will it take the larger plane to catch the smaller plane? So the larger plane is going to be R2 and T2. So what I'm looking for is I want to solve for T2. So somewhere over to the side here, what do I know about T2? Well, I know that T1 equals T2 plus 40 minutes. Okay, I know that T1 equals T2 plus 40 minutes. Now, how do I know that? Well, the larger plane leaves 40 minutes after the smaller plane. What that means is, however long the larger plane is in the air, we're going to add 40 minutes to that, and that's how long the smaller plane was in the air. Okay, so I got that straight out of the problem statement. Now, what do I know? I know that everywhere I have T1, I can substitute T2 plus 40. I can substitute that side of this expression here. So I've got T1 equals T2 plus 40. So everywhere I have T1, I can substitute T2 plus 40. Well, I'm going to substitute that right here. So what do I get? I get 180. Now, here's the problem. Wait a minute. Before we do this, notice this is in minutes. And you notice this is in hours. And our time will not work. So here's what you got to do. You've either got to turn 180 miles per hour into 180 miles per minute, or you have to turn this 40 minutes into hours. Well, there is an easy way to do that. if you know the number of minutes in an hour, which is 60, then this is 40/60ths of an hour. Okay, so whenever you have, let's say you had 22 minutes, well, that's 22 over 60 hours. Well, 40 over 60 just so happens to reduce to 2/3, so I know that T1 equals T2 plus 2/3 of an hour. Now I have miles per hour times T2 plus 2/3 of an hour. And so I have hours, and this equation will work as far as units are concerned. And then here we have 250 times T2. And now, how many variables do I have? T2, T2, I have one variable. So, what we're going to do is we're going to take this equation, we're going to multiply these out. So we get 180 times T2, so we get 180 T2. 180 times 2/3. Well, 180 times 2/3 is 120, so plus 120 equals 250 T2. So now this equation looks pretty simple, so we're going to take our T2, we're going to move that over. So we get 120 equals 70 T2, right, because subtract 180 from both sides. So we get 120 equals 70 T2, and then we're going to divide by 70. And we are going to get T2 equals 1.7143. Now, you've got to remember, I converted time to hours, and my rate was in miles per hour. So this is going to be in hours. Okay, so it's 1.7143 hours. Here's the deal, folks. If you go back to the original problem, it says find the time in hours and minutes. In the real world, you're not going to tell someone, oh, I can catch that plane in 1.7143 hours. You're going to give this in what we call standard format. So standard format on a tape measure is feet and inches and a fraction. Standard format in time is going to be in hours and minutes and, if necessary, seconds. So what are we going to do? Well, we have 1.7143 hours. That means we know we have one whole hour. And what's remaining is 0.7143 hours. Now, a little bit of unit conversion here. We always multiply by unit fraction when we convert units. So what do I know about hours? Well, I know 1 hour is the same as 60 minutes. And what happens? Hours on top, hours on bottom, cancel out. What unit am I left with? Minutes. So 0.7143 times 60, and I get 42.86 minutes. Now, obviously, we're going to round this, and so the easiest thing to do is take this 42.86 and round it up to 43 minutes. So your answer would be 1 hour and 43 minutes. And that's how long it's going to take for the large plane to catch the small plane. In this particular problem, what if someone asked you how many hours and minutes is the small plane in the air? Well, the time for the small plane was T2 plus 40. So you could take this number and add 40 minutes to it, and that would be the time the small plane is in the air. What if someone asked you the distance that one of the planes traveled? What is distance? It's rate times time. So if they ask you, how far did the planes travel? You could say, well, the rate of the large plane was 250. The time was 1.7143 hours. Multiply those together, and that would be the distance. So you can do a lot with this, not just find the time, but obviously if you can find the time, you can do a lot of other things. So if you have any questions about this, please let me know.